Our next topic is volume of solids. Find the volume bounded by the cylinder x square plus y square equal to 4 and the planes y plus z equal to 4 and z equal to 0. Okay, so we are going to find the volume bounded by the cylinder. Okay, for cylinder we are going to find. So let us draw the image first. This is your cylinder. So this is going to be your z axis and this is going to be your y and x, y, z. Okay. So here our x and y, what are the x and y? So x square plus y square equal to 4. So it is in the form of a circle. So our x and y is in the form of a circle. So this is our x, this is our y. So this region is our x square plus y square equal to 4. Okay, so this is our O, 0. And this is the region for x and y. X and y connected region is this, and this is the equation of a circle. And the next one is our z. So y and z, where it is connected? Our y plus z equal to 4. So this plane is our y and z has to be connected. So it should be like this, right? So where y and z is connected. So this line is y plus z equal to 4. It is connected. So this cylinder will look like this. Okay. Your cylinder will look like this. Like a slanting curve, because y and z are connected. So as usual we can connect the cylinder. Okay. Our cylinder is done. Now we are going to find a volume for this cylinder. So let the V volume, we have a triple integral x, y and z. Okay, so we have to find triple integral, the volume dz, dy and dx. Okay, so now let us find the integrals. Where does the x, y, z and x, y and z lies? So first we'll start from z, because for z they have already mentioned our z is equal to 0 and y plus z equal to 4. So our z is going to be 0 to z equal to 4 minus y. Y plus z equal to 4. So we can write z equal to 4 minus y. And for x is equal to, it is minus 2 to x equal to 2. Why? Because this equation in the form of x square plus y square equal to 4. Okay, which is a standard circle form. It is a standard circle equation. So for that equation our radius will be 2, right? So if a radius is 2 for a circle, then what will happen? Our x will be varies from minus 2 to plus 2. This is the maximum, the smallest possible value and the largest possible value. So we are taking considering this standard circle equation, we are choosing our x equal to minus 2 to plus 2. Okay, so now next one is our y. So y equal to minus root 4 minus x square to y equal to root of 4 minus x square. So let us see this how. You know, I think using the given equation y, where is it? This one. X square plus y square equal to 4, right? So we can write our y square equal to 4 minus x square, which is our y equal to plus or minus root of 4 minus x square. So that's how we got our y. So all the integrals are over. Now we can find the volume. So first one is x. X varies from minus 2 to plus 2. Okay, initially we start from negative first. Okay, so minus 2 to plus 2, and your y is minus root 4 minus x square to plus root 4 minus x square. And your z is from 0 to 4 minus y. So that's all. dz, dy and dx. Okay, now we are going to find the volume, which is equal to our integral minus 2 to 2 integral root of minus root of 4 minus x square root of 4 minus x square into z. We are integrating this one first. Okay, choosing this one first. So we don't have any variables, so we can say it is 1. So integrated with respect to dz, then we will get z. So where the variables are z equal to 4 minus y and z equal to 0 into dy dx equal to integral minus 2 to 2 integral minus root of 4 minus x square 4 minus x square. Here we are going to substitute our z 4 minus y minus 0 dy dx equal to integral minus 2 to 2, and the next integration we are going to do with respect to our y, because there is no y here, so we will integrate with respect to y. So 4y minus this y will become y square by 2. The integrals are y equal to root of 4 minus x square, y equal to minus root of 4 minus x square into dx equal to integral minus 2 to 2 4, substituting our y values, 4 into your upper limit root of 4 minus x square minus root of 4 minus x square the whole square by 2 minus the lower limit. Minus 4 into 4 minus x square minus 4 minus x square the whole square root of by 2. So this 2 and will cancel, square and root will cancel. Integral minus 2 to 2 4 root of 4 minus x square minus, I can write it as 1 by 2 into 4 minus, that is not necessary, root of 4 minus, I can cancel this also. So 4 minus x square by 2 minus, and one more minus is there, so it will become plus 4 root of 4 minus x square Here also there is minus, here also one minus, so we can write it as plus 4 minus x square by 2 into dx. So this can be cancelled. Okay, this is in minus, this is plus. So the remaining terms are integral minus 2 to 2 into plus 8 root 4 minus x square into dx. So I can take this 8 outside. Okay, so 8 integral minus 2 to 2 root of 4 minus x square dx. Okay, now we have one important step. Okay, one important step which we have. We are going to change this integral and root 4 minus x square equal to like this. We have one standard formula, integral root of a square minus x square into dx. Okay, so this can be written like this. This integral will be from 0 to 2. Okay, so this will become 16 integral 0 to 2. We are splitting the integrals from minus 2. So it will become 16 integral 0 to 2 root of 4 minus x square dx. So this I am going to write like this. Integral root of x square minus a square minus x square dx can be written as a square by 2 sine inverse x by a plus x by 2 root of a square minus x square plus c. Okay, this is a standard formula for this. Okay, for using this I am changed this. Okay, minus 2 to 2 I was changed into 0 to 2 and I have changed our 8 into multiplied with 2. Now 16 in the form we are going to write our a square equal to 4, a equal to 2. Okay, so first one, what is this? A square. So which means 4 by 2 sine inverse x by a is 2 plus x by 2 into a square minus 4. A square is 4 minus x square is x square. That's all. We don't have any constant, so we are finishing it here. 0 to 2. Okay, now these two can be cancelled. So we have 16 2 sine inverse of for x now I am going to substitute. For x it is 2 by 2 plus 2 by 2 root of 4 minus x square. X square is again 2. So 4 minus the lower limit. Lower limit will become 2 sine inverse of 0 by 2 plus 0 by 2. This will become 4 minus 0 equal to, this will become 1. So our sine inverse, what is the value of sine inverse of 1? So sine inverse of 1 is equal to pi by 2. Okay, and sine inverse of 0 equal to 0. This one is 0. Okay, so we have 16. So 2 into sine inverse of 1 is pi by 2. So 2 into pi by 2 plus this is 1, this will become 0. Okay, minus this sign, lower limit, no. So this is 0 and this is also 0. So 16, 2 will get cancelled. Pi, it is a volume, right? So cubic units. That's all. Okay, so we can see one more problem with this. Find the volume of the sphere x square plus y square plus z square equal to a square without transformation. Okay, so it is a sphere and there is no transformation, so we can assume that it is an octant. Okay, so it will look like this. Okay, roughly. Okay, so what is octant? Octant means there are 8, so 8 regions in the form of sphere. Okay, so there are 8 regions in the form of sphere xy, yz and zx. Okay, so we have 8 regions on the same shape, same size and shape all same. Okay, so for 8 regions, that is called octant. Okay, this is the formula for sphere. So we are finding that x square plus y square plus z square equal to a square is connected to octant. So for that purpose, we are going to find a volume, one volume, and multiplying with 8. So 8 into volume of an octant. Okay, so now let us find our z, y and x. Okay, so first one, z equal to from 0 to z equal to, what is the sphere given? This one. So z equal to root of a square minus x square minus y square, and y is equal to 0 to y equal to this one again. What happens? A square minus x square. Okay, and similarly for x is equal to 0 to x equal to a. Okay, so using this we are finding our y. Using y we are changing a and x, and for x using this y value substituting our a, using this we will get this. Okay, so we got, now we can write the integrals. 8 integral 0 to a integral 0 to root of a square minus x square for y, and for z 0 to root of a square minus x square minus y square dz dy dx. Okay, equal to 8 integral 0 to a integral 0 to root of a square minus x square into, there is no z, first there is no z in this integral also, so this integral belongs to our dz. So integrating with respect to z, so it will become z 0 to z equal to 0 to z equal to root of a square minus x square minus y square dy dx. So integral 0 to a, integral 0 to root of a square minus x square into, I am going to substitute our z. Our z value is root of a square minus x square minus y square minus 0 into dy dx. Okay, the next one is equal to 8 integral 0 to a, integral 0 to root of a square minus x square, and this one into dy dx. Okay, now similarly like the previous problem we did, right, using root of 4 minus x square, like that we are going to do now using the same method, 8 integral 0 to a, this method. Okay, so it is in the form of 0 to root of a square minus x square. Okay, so which is we are going to use like this in the similar way. So the form of a square by 2. What is our a square? So this is our a square. Okay, so root of a square minus x square is your a square by 2 sine inverse of y by a square minus x square, y by a plus y by 2 into root of a square minus x square minus y square. So your y equal to 0, your y equal to root of a square minus x square into dx equal to 8 integral 0 to 8. So the square and root cancelled. So a square minus x square by 2 sine inverse. So what is our y? Our y is root of a square minus x square by root of a square minus x square. So we can cancel both the terms, plus y by 2, sorry, again our y is, what is our y? Root of a square minus x square by 2 into this term, a square minus x square minus our y is again a square. Root of a square minus x square the whole square into dx. Okay, and the lower limit will become 0. That's why I am not mentioned here. The lower limit is 0 because y it is in the multiplication, so it will become 0. Okay, now the square and root will get cancelled, and what we have, 8 integral 0 to 8 integral 0 to a square minus x square by 2. Our sine inverse of 1, there both are cancelled. So what is sine inverse of 1? Pi by 2. Okay, so our sine inverse of 1 is pi by 2. So I am going to write it as into pi by 2 plus root of a square minus x square by 2. Here what we have, root of a square minus x square. So we have minus here, and this one is become minus a square, and minus here this will become plus a square into dx. So this will get cancelled. So this all will get cancelled. It will become 0. So the whole terms will become 0. So we have 8 integral 0 to a x square a square minus x square by 2 into pi by 2 plus 0 into dx. Okay, so we have 2 commonly here. So 2 into 2, I'm going to take this outside. So 8 by 4. If it is plus, we will take 1 2. If it is in the multiplication, so we have 2 2's. This will get cancelled twice. So a square minus x square into pi into dx. This pi is also not necessary, so we can take outside. So 2 pi integral 0 to a into, so now we are going to integrate with respect to dx. There is no x here, so it will become a square minus x square into dx. So integral 2 pi a square, oh my god, a square into x minus x square x cube by 3, 0 to a. So for x we have to substitute. So 2 pi a square into a minus a cube by 3 minus 0 equal to 2 pi a cube minus a cube by 3. Okay, so 2 pi. So here what we have, so minus 1 into 3 will come. So here also we will get 3. So 3a cube minus a cube by 3. 2 pi 2a cube by 3 equal to 4 pi a cube by 3. It's a volume, so cubic units. That's all. Okay, so this problem is also over, and we have one more problem, and also one important thing for this problem, and that is, for this problem we have one more question. So for both the question the answer is going to be same. Okay, show that the volume of the ellipsoid, if they ask like this also you have to write the same problem. So plus z square by c square equal to 1 is 4 by 3 pi ABC. Okay, here we have a cube, here we will get ABC. Okay, with the reference of the same previous problem you have to solve this. If they ask like this you have to solve this. Both the problems are similar. Okay, now we can see one more problem in volume, and let's finish up to this. So find the volume of the tetrahedron bounded by the plane x equal to 0, y equal to 0 and z equal to 0. X by a plus y by b plus z by c equal to 1. Okay, so we are going to find the volume for tetrahedron bounded by the planes x by z, and the equation is x by a, y by b and z by c. Okay, so now let us draw a tetrahedron first. Tetra means 3. So we have 3 different lines, 3 different axes. For volume, we have only 3 integrals, 3 dimensionals. Okay. This is how x, y, z. Okay. So this plane is x by a plus y by b plus z by c equal to 1. Okay. So any plane curve, shaded region. And the y point is your b and x is going to be your a and z is going to be your c. Okay. For a, we have a 0, 0. For b, we have 0, b, 0. And similarly for c, we have 0, 0, c. Okay. So let us find the volume. Volume equal to triple integral v dz dy dx. Okay. So what are the limits? Our x is equal to 0 to x equal to a. Okay. The denominator. Okay. First we are going to choose to find our x by a. Using x by a, we found this. First x equal to, from x equal to 0 only it will start, and x equal to a. Next one, x by a plus y by b. So this will become y equal to 0 to y equal to b into 1 minus x by a. Okay. And the next one is x plus a plus y by b plus v by c is equal to z equal to 0 to z equal to c into 1 minus x by a minus y by b. That's all. Okay, now we got all the integrals, so we can go for the problem. So volume equal to integral from a, x is 0 to a and y is from 0 to b of 1 minus x by a, and z equal to 0 to c of 1 minus x minus a minus y minus b into dz, dy and dx. Okay. So first we are going to differentiate this with respect to our z. We don't have z here. Okay. So integrating with respect to z. Integral 0 to a, integral 0 to b into 1 minus x by a into z. Our z equal to c into 1 minus x by a minus y by b, z equal to 0 dy dx equal to 0 to a, 0 to b, 1 minus x by a, and as this is it, we will substitute c into 1 minus x by a plus minus y by b into dy dx equal to, we can take this c outside, so because we don't need that c, so c integral 0 to a integral 0 to b into 1 minus x by a. The remaining terms we have 1 by 1 minus x minus a by y minus y by b into dy dx. So c integral 0 to a. So now we will differentiate this with respect to, integrate this with respect to dy. Okay, so there is no y here, so we can write y minus x by a into y minus y square by 2 into b. Okay, so our y is going to be b into 1 minus x by a, y equal to 0 dx. C integral 0 to a. So we have commonly y here. So we can take both the y. This is multiplication and this is minus. So y into 1 minus x by a we can write. And this one we can write it as minus 1 by b y square by 2. Okay, to make it simple. So that we can substitute only one y and we have the remaining terms. B equal to, b into 1 minus x by a 0 dx. C integral 0 to a. And what is y? Y value is 1 minus x by a and into this b into 1 minus x by a minus 1 by 2b. Okay, this 2b and y square, no? So b into 1 minus x by a the whole square into dx. C integral 0 to a. B into 1 minus x by a 1 minus x by a minus 1 by 2b. This b is squared, so b squared, so this cancelled, and we have 1 minus x by a the whole square into dx. Okay, so we have b on both the terms. Here also we have one b and here also we have one b. Okay, so we can take both the b outside, so it will become c and b. So we can write in the form of b and c. bc integral 0 to a. What is the remaining term? We have 1 minus x by a and 2 times we have. So we can write 1 minus x by a the whole square minus 1 by 2. This b was taken outside. The remaining term is 1 minus x by a the whole square. Okay, so we have 2 times. Now we have 1 by 2 here, but we don't have 1 by 2 here. So we can multiply and divide by 2 in this term. Okay, so what will happen? So bc integral 0 to a, if we multiply and divide by 2, it will become x 1 minus x by a the whole square by 2 minus 1 minus x by a the whole square by 2. Okay, so both the denominators are equal, so we can minus this term. So what will happen? bc integral 0 to a, here what happened? 1 minus x by a the whole square by 2. The whole square by 2 into dx. So again we can take this to outside. Okay, so bc by 2, shall we differentiate it? Integrating it, shall we integrate it? So it will become 1 minus x by a. This is what we have. So I am going to integrate this with respect to dx. So it will become 1 minus x by a the whole cube by 3 times, right? So 3 into 4x, we have minus 1 by a. 4x, we are writing minus 1. Okay, by a. For 1 will become 0. Our x equal to a and x equal to 0. Okay, so bc by 2. So this is in the 1 by a form. So we can take this. What happened here? It will become reciprocal. Okay, so what happened? 1 minus 1 by x by a the whole cube by minus 3 plus 3, and this a will, p is not minus, so this a can be written here minus a, right? So minus a b c by this 3 and this 2 will become 6. So it will be easy, so that we are taking the denominator and numerator all this term, the unwanted terms. So here we don't have any x, or anyway we are not going to substitute any x. So I have taken this outside. Here also, here only we have x. So I am keeping that. Minus a. Where is the value? A to 0. A to 0. So minus ABC by 6 into 1 minus a by a. So the lower limit will become 0. Okay. So a and a will cancel. A by c by there is 1. Only this is going to be 0. 1 minus the lower limit, okay? 1 minus 0 by a, okay? So this is going to be 0. 1 minus 1 minus 1 minus 0 minus a b c by 6 into 0 minus 1 equal to a b c by a b c by 6 cubic units. That's all. Refer the book if you have any doubts. Okay. So similarly, this problem also have one more question. You can solve using the same methods, dx, dy, dz, where V is the volume of the tetrahedron whose vertices are, if they ask like this also you have to write similar method only. Okay, that's all. In volume, we have these problems are enough. These 3 problems are enough, so you can prepare.